experimental probabilities. Now, in reality, if we were to roll a dice 100 times, we probably wouldn't get exactly the same number of 1s, as 2s, as 3s, as 4s, as 5s, as 6s. Which is what we would expect, because we know that the probability of getting a number 1, for example, on a dice is 1 out of 6. So that means every 6th roll we do, we should get a 1. But if we were to do an experiment, we'd probably find that we get maybe 2 or 3 3s in a row. And then we might get loads of 6s and a couple of 1s. So it wouldn't really get what we necessarily expected. But what we might get, though, is if we did the roll more and more and more, if we roll the dice more times, we should find that it gets closer and closer to what we expect, so that roughly every 6th roll is a number 1. So to improve your experiment, you need to do it more times. As well, sometimes we might do an experiment, a survey, and want to find probabilities from it. So here we have a set of data about the colour of cars passing outside of a school. And then we can find some probabilities from our experiment. So we've got a table here. It says the colours of the cars, and then it says the number of cars that passed by below it. But how many cars actually passed by the school? Well, we don't know at the moment, but we can find it out by adding up the number of red cars that went past, blue, yellow, green, and the other ones, and we'd find the total number of cars that we saw go past our school. So if we add up our total number of cars, so 3, 9, 11, 17, 20, carry over to 2, 5, 6, 7, 9, so there's 90 cars that pass by our school. So we're asked to find what is the probability the next car passing the school being a red. Well, from our experiment, we know that 23 cars that passed were red. And how many cars did we say passed the school altogether? Well, we saw 90 cars. So the probability the next car passing would be 23 out of 90. What is the probability the next car passing is green? Well, if we look at our experiment, we find that 12 cars were green. So that is 12 out of the 90 cars we saw. Yellow. Well, if we look, we saw 16 yellow cars. So the probability the next car is yellow would be 16 out of 90 cars we observed. And finally, the probability is not blue. So this means it could be a red, green, yellow, or the other coloured cars. So we know there was 36 blue cars. So we need to take that 36 away from our 90 to find out how many are left over. So we need to do 90 minus 36. So we can't do 0 take away 6, we're going to borrow. So that's 10 take away 6, which is 4. 8 take away 3, which is 5. So that's 54 out of the remaining 90 cars. So that's 54 out of 90. Now we can also use our experimental probabilities to try and predict how many cars we'd expect to pass in the future to be a certain colour. So on part B, it says, if 150 cars passed the school, how many do you think would be blue? Now, we know that the probability that the next car passing would be 36 out of 90 from our experiment. 36 out of 90, because 36 cars were blue out of the possible 90. So the probability the next car passes would be 36 out of 90. But we're going to repeat this, not once, but we're going to look for the next 450 cars, and then we want to say how many were blue. So what we do is we take our probability and we times it by the number of cars we're going to watch, which is 450. Now this you can do on a calculator. So this is like finding 36 out of 9 over 90 of 450. So when you're finding fraction of amounts, you do 450 divided into 90 parts, and then we want 36 of them. So we're going to do 450 divided by 90, which is 5. And then we want to take that 5 and we're going to multiply it by the 36. Multiply it by 36, which gives us 180. So we'd expect 180 cars out of 450 to be blue.